This is about my third or fourth attempt at making a video for problem number 9 on page 566 in section 10.6. We didn't have time to cover any homework questions on Thursday and Friday of this last week, so I wanted to make sure I made some videos so that you guys knew exactly what to do for these problems. 9 through 12 specifically are the problems that I keep hearing, oh, I didn't know how to do that. The first thing, there's a lot of moving parts. The first thing you need to be able to do is you need to be able to graph the function without your calculator. And by plotting some points from 0 to 2 pi, you should be able to do that. You should be able to find that when theta equals 0, you're right there at -1, 0. And then when theta equals pi over 2, you are right there. So theta equaling pi over 2. So you, in the shape of the graph, is kind of like that, like you see over here to the left, but I just want to make sure you're aware. Theta equaling 0, then theta equaling pi over 2, then theta equaling pi. That's when theta is equal to pi. And then when theta is 3 pi over 2, you're way up here. Okay, theta equaling 3 pi over 2, you're way up there. And so the curve traces itself out kind of like this. Okay, and so the direction, again, is really, really important that you understand that this curve is drawn in a counterclockwise direction, starting with theta equaling 0 right there. That's your starting point. It's also your ending point as well. But we're supposed to come up with the horizontal and vertical tangent lines. Okay, well, on the next slide you're going to see a lot of work. It might be a little bit intimidating, but nevertheless, you're supposed to understand that when dy dx is equal to 0, we have a horizontal tangent line. When dy dx does not exist, that's the stuff down here. Dy dx equaling 0, horizontal tangent line. Dy dx does not exist, that's a vertical tangent line. So how do we find dy dx? Well, dy dx is dy d theta over dx d theta. So we have to find each of those like we did in the notes. Dy d theta is all this stuff. I'll let you look through that. Okay, we find that dy d theta equaling 0 when theta is equal to all these angles down here on the bottom. Okay, skip over to dx d theta. Okay, so I'll just assume that you can just pause your video and work these things out. This is stuff we did back in pre-calc honors. It might not be something you're able to do right now, but you need to be able to do these things. Okay, dx d theta is equal to 0 when you see down here at the very bottom theta equaling these three values down at the bottom. Okay, so in summarizing that, as I said before, let me see where we at here. Back up to here, and dx d theta equals 0. Let's see. So anyway, we have the three angles for theta. We have the four angles for theta in dy d theta equaling 0. And then when we go all the way over here to summarize, basically we see that when theta is equal to pi over 2, and then 7 pi over 6 and 11 pi over 6, we have vertical tangents. So I labeled the vertical tangents by letters D, E, and F. I labeled the horizontal tangents by the letters A, B, and C. And I also included the polar coordinates of each of the points. Okay, and so the first thing we would want to do is, after finding the polar coordinates of each of the points around this curve in which we either have a vertical or a horizontal tangent, then we have to figure out what the equations are of the tangent lines to the curves at these particular points. Okay, so that's where we come in for the summary. Okay, so the summary is, if we want to find the horizontal tangents, we want to find the equation of the line going through point A, the tangent line. And the y is equal to r sine theta. And we plug the r in, we plug the theta in, and we get -1/2 times 1/2, and we get -1/4. Okay, fine. We do the same for b. We plug the r in, we plug the theta in, and sine of theta is 1/2. So we get -1/4 as well, because it's really the same line. It's just the equation of the line at each of those points. And then when we plug in the the r for point C, the r is -2. Okay, the theta is 3 pi over 2, and the sine of that is -1. So -2 times -1 is 2. You could have figured that out anyway just by looking at it. Okay, and on the next slide we see what we have when we plug in the r and the theta to the r cosine theta to find the equations for x. Because when x equals r cosine theta, we have the equation for x, we have the actual equation of each of these vertical tangent lines to the graph. Okay, and they're all unique. And so we see what we have when we try to find the x equation at D, E, and F, and we get the three values that you see here: 0, 3 radical 3 over 4, and -3 radical 3 over 4. And the conclusion, when all is said and done, the conclusion right down here, I should probably do that in a different color. The horizontal tangent equations are what you see here in this box. Okay? And that's what we're looking for, the equations using x and y's at each of the corresponding points. Alright? So that's it for number 9, and I'm not going to be able to do another video until maybe early in the week. So hopefully this will help you do numbers 10, 11, and 12. Not that you'd necessarily want to do 10, 11, and 12 because they take forever, but maybe do one of those. Maybe do number 12. And if you can get 9 and 12, then you'll be good. Have a great day.